Hello, this will be a brief review of integration by parts from Calculus 2. We will be using integration by parts, especially when finding expected value, e of x squared. So one of the situations where we use integration by parts is when we have certain products of functions. Power function of x, like x squared times cosine, x times an exponential, x times e to the 3x, x cubed times log x, e to the x times sine 2x. There are some other cases here. We may not really see those too much in this course. These top few types here are going to be common, especially the second one here that's going to show up in this course. So, what's the formula for integration by parts? The integral of u dv is equal to uv minus integral v du. So, the viewpoint here is that we look at the expression and we kind of break it apart into um, pieces here, a function u and then basically a derivative dv, something that we can integrate. And then we do the calculation out. We have to calculate du and v. So the goal here is to arrive at vdu, which is a simpler integral than what was started with here. So usually the u function will be something that has a simpler derivative, and hopefully the dv is something that is easy to integrate. We have a little bit of a strategy here for this choice of u. We look in order for these functions here: log first, then inverse trig, then polynomial, exponential, trig. So in that order, using Lightbit to remember the order, you look there left to right. If you have one of those types of functions showing up, most likely that's going to be the u portion, and then the dv will be everything else. So taking a look at an example here, we're integrating x times e to the 3x dx. So from Lightbit, we don't have log, we don't have inverse trig, we have a polynomial or power function x, and that comes ahead of exponential. So we're going to use u is going to be x, and then the dv is going to be e to the 3x dx. So u is x, a polynomial, or in this case, it's a power function. And then the dv will be e to the 3x dx. Then we have to calculate du and v to get ready for the formula. So derivative of x is just 1 dx. Integral of e to the 3x, a little bit of a small u sub there. We have to make a small substitution of 3x. The derivative is 3. We have to divide out by 3 there. So again, u is x, dv is e to the 3x dx, derivative of u is 1 dx, integral of dv with a little mini u sub is 1/3 e to the 3x. We don't have to put the plus c in. We can hold off until the end for that. Formula is uv minus integral v du. So it's going to be x times 1/3 e to the 3x minus the integral v du, of which is 1/3 e to the 3x times dx. And so what happens is that we do get a simpler integral here. The original, we had a product of two different kinds of functions. Our new integral portion is now just an exponential function alone without an extra x term. And so we can integrate that using the integral of the exponential function, which is essentially itself with a little mini u sub again. So we have multiplying here, x times a third, so you have x over 3 e to the 3x. Now, when you integrate this function again, you again have to divide by 3, and that's where the 1/9 comes from. So another little mini substitution there. Substituting in 3x, the derivative is 3. You have to divide by another 3 to get to 1/9. So again, it's a little mini substitution here. Just going to use W because I don't want to use the U. We've already used the W is going to be 3x, and then dW is 3dx. To solve for dx, we have to divide by 3, so we get dW over 3 is equal to dx. So the integral, we can pull out the constant 1/3 in front here. The integral is e to the w dw over 3. And so when you integrate e, it just stays itself. We can factor out the 1/3, and we have a 1/3 in front, so that becomes a negative 1/9. Integral of e to the w is itself, so it's negative 1/9 e to the w plus a constant. And then we just back sub in the w is 3x. And that same procedure was done the first time through here to get this integral of e to the 3x. And so that gives us our final answer. Integral of x e to the 3x dx is x over 3 e to the 3x minus 1/9 e to the 3x plus a constant. We'll go through one more example here. I'm going to leave some extra ones to take a look at. Some of them are a little bit messy that things probably won't get that messy in this particular course. On this example here, we have x squared times sine of x. We have a product of two different kinds of functions here. We have from Lipet polynomial or power function coming ahead of trig. So our u choice is going to be x squared, and the dv is going to be sine x dx. Now you can do this out, but because the u function is x squared and its derivative is just 2x dx, this is going to be a two-step process here. The resulting integral in the formula is still going to have a product there of x and negative cosine. And so you have to do parts twice. So there's a little bit of a trick shortcut. So I'll look at that here. So again, when you have a situation where your u sub is a power function and it's a higher power than 1, you may want to use this table method here to solve it. So basically, you start out with u and dv. The u is going to be x squared from Lipet, that's the p, and then the trig is going to be the dv sine x. We don't have to put the dx there in this case. So then on the u column, you take derivatives. On the dv column, you just keep integrating. So the derivative of x squared is 2x, and then 2, and then 0. The integral of sine x, a little tricky. The derivative of sine x is positive cosine. The integral is negative cosine. The integral of negative cosine is negative sine. The integral of negative sine goes back to cosine. So it's a little reversed there. Derivative of cosine is negative. Integral of sine is negative. And then we have alternating signs here, plus, minus, plus, because the formula itself has a subtraction, and then you're repeatedly subtracting, and you end up having alternating signs here. So you multiply together here. The first term in the formula is uv. So it's x squared times negative cosine x. Then it's going to be minus 2x times negative sine x plus 2 cosine x. And then you'll put the plus c at the end. So our first product there, it's x squared negative cosine x, then a minus sign, 2x negative sine x, then a plus 2 cosine x plus c. All right, again, this is a short, brief introduction on integration by parts. If you have any questions, please feel free to mention in the discussion board or office hours or email if you have any further questions specifically on integration by parts.